Hey, what's going on, guys? In this video we are going to see how to find unknown mesh currents and branch currents using mesh analysis by inspection method. Now in order to do that we have to follow all these four steps. The first step is assign mesh currents. We already assigned it, that is this I1 and I2. The second step is find resistance matrix elements. So here what we are going to do is R11. R11 is whatever the resistance we have in the first mesh. So first loop we have 2 ohm, 12 ohm, 4 ohm. So we just have to add them together. So this is going to be 2 plus 12 plus 4, and that's going to give us 18. And R22 is going to be whatever the resistance we have in the second mesh or second loop. That's going to be 9 plus we have 2 ohm, 12 ohm. So 9 plus 2 plus 12, and that's going to be 11 plus 12, that's going to be equal to 23. Now we have these two resistance, and the next one is Rij. So we have to find the resistance in between these two meshes. So that's this 12 ohm, right? So this 12 ohm is going to be the R12 or R21, and that's 12. Here we have to do one more thing, that's we have to put a minus right here, and then we have to put them in the matrix, right? So when we put them in the matrix, this is going to be a 2 by 2 matrix since we have only two meshes. And if you notice this one R11 first row first column 18, R22 second row second column 2 3, and R12 is first row second column minus 12, second row first column minus 12. And then here we are going to have, we are trying to find I1 and I2, and in the other side we are going to have these voltages, this voltage and this voltage. Now we have to look at this current direction and the voltage. When it goes from minus to plus, that's going to be a positive value because that's going to be a voltage rise. So this is going to be a 45 plus 45, and this is going from plus to minus, so this is going to be a voltage drop, so this is going to be minus 30. Now to find I1 and I2 we have to use Cramer's rules. Cramer's rule is basically we find the determinant of this original matrix without changing anything. That's going to be minus 80, actually 18, right? This is 18 minus 12, minus 12, 23. And if you have taken the linear algebra, you know to find the matrix of a 2 by 2 matrix we use AD minus BC. This is ABCD. So you cross multiply this one and subtract the other cross multiplication, AD minus BC. And if you do that for this one, that's going to give you 270. And then to find I1, what we have to do is we have to swap these voltages with the first column and find the determinant. If you swap with the first column, that's going to be 45 minus 30 minus 12, 23. And if you find the determinant of this one, that's going to give you 675. And to find the second current, what we do is we do the same thing, like we swap this one with the second column. So in this case first column remains the same, 18 minus 12, second column is going to be 45 minus 30, and if you find the determinant, that's going to be 0. Now from this information we can find the I1 and I2 using Cramer's rule. So to find I1, what we do is we put this one 1, whatever the one we swapped with the first column, find the determinant. So this is what we got when we do with the swap with the first column and find the determinant and divide by the original determinant, that's D. And if you divide that, that's going to be 675 divided by 270, that's going to be equal to 25 ampere. And the second one, I2, is going to be 2 over D, because second we swapped with the second column and found the determinant, that's 0, divided by this 270, 0 divided by anything is going to be 0, so I2 is 0. Now we have the mesh currents. Now we can find the branch currents. To find the branch currents, we know that this branch is going to have same as I1 because I1 is the only thing that's going through this. So if you put small I1, that's going to be say equal to big I1. Also, if you put I2 in this direction, that's going to be equal to big I2. But what about this one? We have let's say I3 here. So this one is going along, let's put an equation, I3. So this I1 going along this I3's direction, so this is going to be I1, and this is going opposite of this I3's direction, so that's going to be minus I2. And it doesn't matter what direction you put, like you can also put upside, then this equation will be other way around, right? Because now this is going along with the direction, so you always get the right answer. So if you put other way around, the sign will change. Now I1 is 25 and then I2 is 0, so 25 amp is gonna be the answer for I3. And even if you put other way around, you will get a negative 25. Negative means it's in the opposite direction, so it always gives the correct answer. And this is how we do this kind of problems. I hope you guys find this video helpful. See you next time.